Hello listeners, you are listening to 90.4 FM Radio Khachi, Hum Sabka Radio. This is Jaydip De, Assistant Professor in Geography, Barashat Government College, West Bengal. Today, I'm gonna discussing with you one of the most interesting and trending topic of geosciences, that is geography, geology, geoinformatics and regional planning. The topic of today's discussion is remote sensing, basic concepts, types and requirements. The term remote sensing is derived by joining two words. Remote means distant and sensing means observing or acquiring information. Therefore, remote sensing refers to the acquisition of information about an object or phenomena without making physical contact with that object. The term is applied especially to acquiring information about the Earth and other planetary objects. Let me make you clear with some examples. Suppose you have a camera and you are capturing a photograph of any object or person situated away from you, then it will be a remote sensing technique. But for precise geoscience applications, we consider images captured from satellites and aircraft as remotely sensed data. One thing is to remember that remote sensing is only possible in the presence of electromagnetic energy. Hence, based on the source of electromagnetic energy, remote sensing can be broadly divided into two types: passive and active remote sensing. Now, at first, we should know about the passive one. In passive remote sensing, a sensor records electromagnetic energy that was either reflected or emitted from the surface of the earth and is dependent on the energy that comes from the sun. Here, the presence of solar energy is essential. An example of passive sensor is passive microwave radiometer. On the other hand, active remote sensing does not depend on solar energy or the thermal properties of the earth. Here, the sensor create their own electromagnetic energy, radiates them and record their interaction with surface features of the earth. Some examples of active sensor are radar, lidar and sonar. Beside this kind of classification, remote sensing can also be divided into three types depending on the platform used for acquiring information. A stable platform is always needed to collect and record the reflected or emitted energy. Firstly, spaceborne or orbital remote sensing, where the information is obtained from space using different satellites. Of course, these are artificial satellites like Landsat satellites of NASA, USA, IRS series of satellites of ISRO India, etc. Many of the countries have sent their own satellites to space for various remote sensing applications. Spaceborne remote sensing may be also performed from space stations like International Space Stations. But whenever information is obtained from within the Earth's atmosphere, that is called airborne or aerial or suborbital remote sensing, like remote sensing using aircraft, balloons, kites, etc. Sometimes ground-based platforms are also used to compare the information obtained from aircraft or satellite sensors. In such cases, the sensors may be placed on a ladder, tall building, crane, pigeons, etc. Now, I am moving to the requirements, that is ideal remote sensing system. There are many more requirements. Some of the important requirements are existence of a uniform energy source with a constant wavelength. Secondly, a non-interfering atmosphere. Thirdly, a super sensor highly sensitive to all wavelengths and capable of sensing detailed information. Fourthly, a real-time data handling system that can process the accurate data nearly real-time. And fifthly, multiple data user having knowledge of remote sensing and other disciplines of geosciences. Though a number of requirements are mentioned here, it is very difficult to have such an ideal condition in reality. However, I hope that this discussion of today's session can help you to understand the basics of remote sensing system. Thank you for listening. Have a nice day.